Hello, in this video we're going to be talking about the disk method. So we've been finding area, it's only one step further in order to figure out a volume. So the idea is that we are going to be finding rectangles, because that's what integrals do. And then what we want to do is we want to square that thing in order to make it from a one-dimensional shape into a two-dimensional shape. And then multiply it by one more thing, a rotation or pi, in order to get a volume. So you can see here, this is the formula for the volume of a cylinder. What we're doing is using those rectangles in order to be our radii. H is how wide all of our rectangles are, but they're getting really, really small. So really just this H is kind of covered by this dx or dy. And then we want to multiply that by pi because that's what's part of our volume calculation. And so basically all we're doing is we're finding that same curve, then squaring it in order to make it a two-dimensional shape, and then multiplying it by pi. So you can see here I've done a problem. So I've got this y equals e to the negative x squared. All we need to do in order to figure out a volume of this thing rotated around the x-axis is we square that equation, slap a pi in front of it, and then boom, we've got our volume if this was a three-dimensional shape rotated around the x-axis. Here's another example where we are taking that curve that we have right here, and I haven't actually typed in that. I've typed in all of this with that squared on there. So we're integrating that area underneath it, multiplying it by pi, and then boom, this is the volume if this shape were rotated around the x-axis in order to create a three-dimensional figure. So in this example, I've actually done a little geometry off to the side to show what it would be like if we were to do this thing in geometry. But hey, you know what? We're not in geometry, we're in calculus. So we're going to find our volume that way. So we're going to do the integral from the x-axis. So you can see here I've solved this equation for x. I could have also solved it for y, and I just would have done it based on the y-axis. So there's always going to be a pi in front, because that's just volume stuff. And so we're going from our x values of 0 to 2, and I'm going to write this little reminder on the end that I'm doing my antiderivative with respect to x. Then I want to put in what is the radius of my volume thingy. And that's that value right here. So that is going to be negative 1/2 x plus 1. And then in order to make it a proper radius, we always do our radius squared. So we just got to square that thing right there. And that's all set up. So now it's just a matter of integrating all that garbage. So I've got a pi. We've got our equals stuff. I'm going to clean up what's going on inside of that integral because I don't really want to integrate that squared stuff right now. There's going to be just too much u substitution. So we just need to FOIL that thing. So I'll do the first thing squared. So that's a quarter x squared. And then we got to do our middle term. So that's going to be 2. Those two things multiply together. So it'll be a minus x. And then our last thing squared plus 1. And then we're set to integrate. So that is pi doing an integral. So we've got a 1/4. And this is going to be an x cubed, but that 1/4 is going to get multiplied by a third. So I'm just going to write an x cubed over 12 minus an x squared. It doesn't have anything else going on with it, so it's just a 2, and then an x. And we're integrating from 0 to 2. Great. So now let's just do fundamental theorem of calculus, top minus bottom. So that's going to be a pi multiplied by our top value, which is 8/12, minus 4 divided by 2, that is 2. Oh, where did my plus go? Should be a plus right there. Plus 2. Brown plus 2. Well, those two zero out, so those are gone. 8/12 simplifies to, oh my gosh, it's 2/3. And then we've got this pi from right there. It's the same thing as what the geometry kids got. Sweet. So you can see in this example, I have the what we would have gotten if we had done this in geometry, but instead we're going to do it with calculus. This one we're going to figure out what's happening as we're rotating about the y-axis. So since we're rotating about the y-axis, I want to figure out what that length is right there. But fortunately, they were kind enough to give that to me. So my volume is going to be pi and then an integral from the two values that I'm going from. And we're going to be finding our antiderivative with respect to y this time. So the two values that we're going between are 0 and 2 on our y-axis. And then our radius is that black line. So I'm going to do it in blue. So that's 3y over 2. But then we always want to square our radius. So then we'll square that thing right there. That's set up. Now it's just a matter of integrating that thing. So I'm going to do that square just so that I don't have like kind of like a chain rule thing going on. And since that 3/2 is just a constant, why don't we pull that in front? So that'll be 9/4. We're going to put that in front of our integral. We'll stick it there with our pi. And we've got a y squared. And we're finding our antiderivative with respect to y. We're still going from 0 to 2. And this still equals the same thing. So this equals, I'm just going to clean that up a little bit. We've got 9 pi over 4. And let's integrate that. We need to do y cubed over 3. And we're integrating from the values of 0 to 2. So this equals, let's see, 9 pi over 4. Y cubed, we want to put in this 2 value. So that's going to be 8/3. We do a little simplification, cancel those. We get 3, cancel these. We get 2. Oh my gosh, 3 times 2 is 6 pi! And that's the same thing the geometry kids would have gotten. So in this example, we're trying to figure out what's going to be going on when the solid is rotated about our x-axis. I've taken the liberty of figuring out where our x-intercepts are. The problem wasn't nice enough to tell us that. That's just some algebra. So we want to do our volume jiggermerbob. So our volume is always going to be pi. And then the integral of where our two lines are meeting up. In this case, on the x-axis. So this is going from 1 to 4. And then let's see, we need to then do our dx. We're rotating around the x-axis. And then just our like rotatey thingy. So that is, you're really making this easy, aren't you? 5x minus 4 squared. Okay, so now it's a matter of squaring that mess in order to be able to figure out what our integration is. I'm not going to eat up time on our video with that, and plus Mel's giving me some lip right now. So I cleaned that up a little bit so we can actually read it, played with Mel. But I was thinking while I was playing, I think this isn't worth our time. At least the algebra of it. It's foiling, and then we got to plug in the 4 and the 1 and then multiply by pi. We got better things to do. Plus, I want to show you something on the graphic calculator anyway. So I plugged in that y1 and I squared that thing and I got my graph. Do note that the graph that you get is different than the actual graph of this curve because we are looking at our radius squared, not doing the integral of the function itself. After doing that, I'm able to calculate the integral for this thing. We are going from 1 to 4, and we get 8.1. Because again, we could have gotten a nice number if we had actually worked all that stuff out, but we couldn't be bothered. So 8 and 1/10 is just 81 tenths. So this thing is getting us 81 tenths for our volume. So our final answer is going to be 81 pi over 10. And you could like plug that into your calculator yourself if you really wanted to check. I don't know why you would, but you could. You're your own person. You live your life. So in this one, we are looking for determining the volume by revolving around the y-axis. So that is telling us that when we find our volume equation and we got our pi and we got our integral, we want to be finding the antiderivative with respect to y because we are rotating around the y-axis and not around the x-axis. However, man, they have been nice and they gave us the start and bottom. So we're going to be going from 1 to 2. But that equation, that's just not going to do because I want that to be equal to x since I am anti-differentiating with respect to y. We want those two. So we want y stuff here. And right now I've got an ln x stuff. That's not what I want. So that y equals the ln of x. We could translate that into an exponential equation. So that is log base e of y equals x. So that is what we're going to plug into our integral. We'll do e to the y because for this curve right there. Then we want to square it because that is our radius. So then we'll just, it's easy peasy, square the thing. Great. Let's clean that up a little bit. So this volume is going to equal pi integral from 1 to 2. We'll make that e to the 2y dy. So once we integrate that, we'll get pi going from, let's see, antiderivative of e to the 2y. If I do a u substitution, my u will be 2y. So then I'm going to need to sneak in a half. So let's get rid of that bracket because of the 2. So 1 half e to the 2y going from 1 to 2. Double check and make sure I'm doing that right. Doing it right. All right, now we're going to have to do proper fundamental theorem of calculus. So we've got a pi over 2 multiplied by our top part, which is e to the 4th, minus our bottom part, which is an e to the squared. what a lovely sentence that was. So e to the 4th minus e squared. We could plug that into our calculator. Past me has done that for us already. So our volume can equal this garbage, or we can say that our volume is approximately 74.156. And that's all set, all done. We want to evaluate this integral, and we're going to be revolving around the x-axis. So that's telling us that we want to make sure we're integrating with respect to x. All right, so volume equals pi, garbage. We are going from 0 to 1 for our region. And then our radius is in that little orange box. So that is our negative x plus 1. And then just like all of our radii, we want to square it because that's part of our volume thing. Cool. We're all set up. Let's integrate. Well, before we integrate, though, I want to clean that up. So this, if we square it, we get x squared minus 2x plus 1. We still have our dx. We still have our integral going from 0 to 1. We still have our pi. And this still equals the volume. But that's now ready to be integrated. So let's do that. So we get pi bracket x cubed over 3 minus, let's see, we'll get an x squared. We'd have a 2 and then divide by 2, so that's just gone. Plus x going from 0 to 1. So our top value is pi bracket 1/3 minus 1 plus 1. And then our bottom, those are all be zeros. So it's really just like minus 0. So that's not really doing anything. Let's see. Well, all that stuff is just 0. So bye-bye. So our volume is just going to be pi over 3. So that is done. In this example, we're going to be rotating around the x-axis. So we want to find our derivative with antiderivative with respect to x. We've got our volume equals pi integral. Where are we going between? We're going between 1 and 4. So between 1 and 4. And then we need to figure out what our radius is. So that's this little piece right here in that orange. It is the square root of x. So square root of x. Then we just need to square that. So that's it. We've got our radius squared. We've got our pi in front. We're finding our derivative with respect to x, antiderivative with respect to x since we're rotating around the x-axis. So this equals pi integral 1 to 4 of simplifying that is just an x. That's boring. So this equals pi of x squared over 2 going from 1 to 4. Doing our top, that is pi. That is 16 divided by 2, that is 8. Minus our bottom value from right here, that is 1/2. So 8 minus a half is a number. It is 15 halves times a pi. So we get 15 pi over 2. So that will be the volume of the thing that rotates around the x-axis using that square root of x, going from 1 to 4. In this example, we are rotating around our y-axis, so woo, party time. So we want to find our antiderivative with respect to y. We don't like that this thing has got x stuff in it. So I'm just going to real quick solve that thing for y, but what? We get x equals plus or minus y. Well, which one are we supposed to use? Well, see how it is on the positive part of the thing? We just want those positive y values. We don't want the ones that are down there. So, or is that it? No. We want that. We don't want those ones. But whatever, we don't want the negative stuff. So all we want to use is we just want to use x equals the square root of y. I don't know why I didn't have a square root there before. Sorry about that. So that is going to be our thing. Square root of y. Slap a squared on it because that's our radius. I don't know why I'm writing this backwards this time. So sue me. So our volume is pi integral from something to something. Well, let's see. We're going from 0 up to 4, from 0 to 4. So that is pi integral from 0 to 4 of y dy. Integrate, we get pi of y squared over 2, going from 0 to 4. So that is pi of 16 over 2, minus our bottom one, which is not going to do much. Will it? So let's see, that's 0, so nothing. So that just equals 8 pi is our volume. Neat. In this example, we need to be rotating around our y-axis, so woo, around our y-axis, but we don't like our equation because it's got it in terms of x. So if we are rotating around the y-axis, we need this thing solved in terms of x. So in order to do that, we would raise both sides by the 3/2, 3 over 2, in order to one out those exponents. So y would have an exponent of 3/2, right? Right. So that is going to be our radius, y 3/2. We always want to square our radii. Boop. We're rotating around our y-axis, so we're going to be integrating with respect to y. And then our values that we're going to be between are 0 and 1. So we're going to be going from 0 to 1. And then our volume always equals pi times that radius squared integral garbage. All right, clean her up. So we got y cubed. Oh, it's just y cubed. How nice. Dy integral 0 to 1 pi v equals that stuff. So v equals pi going from y to the 4th over 4 from 0 to 1. So that is just going to be, well, I can just do that. That is just going to be a quarter of pi. A quarter pi. Quarter pi. Delicious. So ends our video about the volumes of revolution, the disk method, a reminder that you always want to square your radii and then stick a pi in front of it. If you're rotating about the x-axis, make sure you anti-differentiate with respect to x. If you're rotating about the y-axis, then make sure you're anti-differentiating with respect to y. These should be y values. These should be x values. Thanks for watching. Bye-bye.